Hey everyone, and welcome. Today, we're going to tackle one of the most important concepts in algebra, finding the vertex of a parabola. It is the single most important point on that curve, and we're going to break down exactly how you can find it step by step. So, you know that U shape you always see in math class? It either opens up, making a little valley, or it opens down, creating a peak. Well, that one single turning point is what we are hunting for. But how do you find its exact coordinates? That's the big question we're here to answer. Before we can find the vertex itself, we need to understand where it lives. And its home is something called the axis of symmetry. It's this perfectly straight vertical line that slices the parabola right down the middle, giving you a perfect mirror image on the left and the right. And here is the absolute key to everything. The vertex, that peak or valley we're looking for, isn't just floating around randomly. No way. It always sits right on that axis of symmetry. So think about what that means. If we can find that line, we're already halfway to finding our vertex. And here it is, the star of the show. The vertex. This is the lowest possible point if your parabola opens up, or it's the highest point if it opens down. It's that exact spot where the curve stops going down and starts going up, or vice versa. It's the turning point. So, how do we find this magical axis of symmetry that leads us straight to the vertex? Well, it's not a guessing game. It all comes down to one incredibly useful and surprisingly simple formula. And this is it. This is our golden ticket. X equals negative b divided by 2a. This little equation gives us the exact x value of the axis of symmetry, which, as we just learned, is also the x-coordinate of our vertex. This formula is the engine for this entire process. Okay, theory is one thing, but let's get our hands dirty and see how this thing actually works in the real world. We're going to take a pretty standard quadratic function and use our new favorite formula to find its vertex. All right, here's our example for today. F of x equals x squared minus 6x plus 8. It looks like a normal, everyday quadratic equation, right? But hidden inside that equation are the exact coordinates of its vertex. Our mission is to pull them out. Okay, first things first, we need to identify our a, b, and c values. Remember the standard form, ax squared plus bx plus c? Well, in our equation, a is the number in front of x squared, which is just 1. Our b is negative 6, and our c is 8. You have got to get these right or nothing else will work. Now it's time to plug and chug. We take our formula and we substitute our values. So b is negative 6 and a is 1. That gives us negative 6 on top and 2 times 1 on the bottom. Now be really careful with those double negatives. That's a classic trip-up spot. They cancel out and become a positive, which leaves us with 6 divided by 2. And of course, that gives us 3. And just like that, we have the first half of our answer. We now know the axis of symmetry is the line x equals 3, which also means the x-coordinate of our vertex is 3. We are halfway home. Okay, awesome. We have our x's, but a point on a graph needs 2 coordinates, right? An x times and a y. So that leads us to the next logical question. How in the world do we find the y value? Well, it's actually much simpler than you might think. We know the vertex is a point that is on the parabola. That means its coordinates have to work in the function's original equation. So we just take the x value we just found, our 3, and plug it right back into the original function to solve for y. So let's run the numbers. Everywhere we see an x in our original equation, we're going to swap it out for a 3. That gives us 3 squared, which is 9, minus 6 times 3, which is 18, plus 8. So our problem is now just 9 minus 18 plus 8. And that simplifies down to negative 1. And there it is. That's the second half of our answer. The y-coordinate of our vertex is negative 1. All right, we've done all the hard work. We found our x, we found our y. It's time to put it all together and see what we've got. So we've got our x-coordinate, which was 3 from that axis of symmetry formula. And we have our y-coordinate, negative 1, which we got by plugging that 3 back into the function. And when we put them together as a coordinate pair, we get our final answer. The vertex of the parabola f of x equals x squared minus 6x plus 8 is located at the point 3, negative 1. That is the exact bottom, the precise turning point of our entire curve. Okay, let's zoom out for a second and make sure this really sticks. We can boil this whole thing down to a super simple, totally repeatable, two-step method that you can use on any quadratic function you ever come across. Here's all you need to remember. Step 1. Find the x-coordinate using our magic formula, x equals negative b over 2a. Step 2. Take whatever number you just got for x, plug it back into the original equation, and solve for y. That's it. That's the whole game plan, every single time. So as we wrap this up, I want to leave you with this one last thought. It's so easy to look at formulas in math as just these random things you have to memorize. But think about what we just did. With one short, simple expression, we unlocked the most important structural point for an infinite number of parabolas. It's just a really cool reminder of how a little bit of logic can reveal these amazing hidden patterns all around us.